students, welcome back to video lecture series for the Mathematics 3. Myself Dr. Ankit Acharya, and today we will discuss about very important topic of first order differential equation, linear differential equation. Here you can see that my next topic is linear differential equation. Okay, and for linear differential equation you have to remember this general form of linear differential equation, that is dy by dx plus p into y, that is equal to q. So if I write once again, dy by dx plus p of x, so p is a function of x into y, that is equal to q of x. Okay, so p and q, clearly p and q both are function of x. If your differential equation, first order differential equation is in this form, we can say that this is first order linear differential equation. Okay, linear word is very important, linear differential equation. Okay, and to find out the general solution of this type of linear differential equation, okay, first you have to find integrating factor. Okay, what is your integrating factor? I just write once again, integrating factor, that is e raised to integration p dx. Okay, this is my integrating factor, and the general solution is integrating factor into y, that is equal to, this is my general solution. Okay, just you have to mention this formula. Okay, general solution is integrating factor into y, that is equal to integrating factor into q plus c. Okay, this is my general solution. Here integrating factor into y, that is equal to integrating factor into q plus c. So first you have to find this integrating factor and put the value of integrating factor in this equation and find out the integration, right hand side integration, that you have to find out. Okay, so just you have to remember this equation number 1 and suppose this is equation number 2. So first of all, make sure that your differential equation is linear differential equation, that means this type of differential equation. Find out integrating factor. Integrating factor is e raised to integration p dx, and what is your solution? That is integrating factor into y, that is equal to integrating factor into q into dx plus c. Okay, this is my solution. Clear? So let's take try to solve example. So solve dy by dx plus 2y tan x, that is equal to sin x. So compare this equation with this general equation, dy by dx plus px into y, that is equal to q of x. So what is your px and what is your qx? So dy by dx plus p of x into y, so this is y, so 2 into tan x. Okay, so p of x is, what is your p of x? P of x is 2 into tan x, and right hand side q of x, my function is sin x. Clear? Okay, now I want to find integrating factor first. Integrating factor. Clear? So integrating factor, that is e raised to integration p of x into dx. So that is equal to e raised to integration 2 tan x dx. Okay, and what is the formula for integration tan x? That is log mod sec x here. So e raised to 2 log sec x. Okay, so sec x whole square, right? So sec square x, we can write sec square x or sec x whole square. So now this is your integrating factor, sec square x. Okay, clear? I hope you can understand. I just write each and every step so you can easily understand. Okay, so now your general solution. What is your general solution? Now your integrating factor, I just mentioned integrating factor, that is sec square x. So now my general solution is y into integrating factor, that is equal to integrating factor into q into dx plus c. So y into sec square x, okay, and that is equal to integration sec square x, okay, into q. What is your q? Q is sin x. Okay, so sin x dx plus c. Okay, now I have to find this integration. So we know that integration sec square x, so that I can write 1 upon cos square x. Okay, so integration 1 upon cos square x into sin x dx plus c. So that can be written as 1 upon sin x upon cos x, so that is tan x and 1 upon cos x, that is sec x. So integration sec x into tan x dx plus c, and we know that sec x into tan x is a differentiation of sec x. So integration of sec x into tan x, that is sec x. Okay, so sec x plus c. So final answer is y into sec square x, that is equal to sec x plus c. Okay, y into sec square x, y into sec square x, that is equal to sec x plus c. Okay, and suppose you want to calculate one more step. So sec square x you can take right side. Okay, so you will get y, that is equal to sec x upon sec square x. So 1 upon sec x, so that is cos x, and plus c in upon sec square x. So I can write cos square x. Okay, but this previous term, that is also valid. Okay, and this is also correct. Both are same. Clear? Okay, so y into sec square x, that is equal to sec x plus c. Okay, let's take one more example. X plus 1 into dy by dx minus y, that is equal to e raised to 3x into x plus 1 whole square. So first of all, what is my general form for linear differential equation? Dy by dx plus px into y. Okay, this is x, that is equal to q of x. Okay, this is my general form for linear differential equation. So here x plus 1 is additional term, so you have to divide first of all. Okay, so that's why when I divide x plus 1 on both the side, okay, you will get your new equation dy by dx, okay, minus 1 upon x plus 1 into y, that is equal to e raised to 3x upon x plus 1. Okay, sorry, e raised to 3x, x plus 1 whole square upon x plus 1. So e raised to 3x into x plus 1. So now what is your px? Px is minus 1 upon x plus 1, and q of x. Q of x is e raised to 3x into x plus 1. Okay. First we find our integrating factor. So integrating factor, that is e raised to minus e raised to integration px. So e raised to minus 1 upon x plus 1 dx. So that is e raised to minus integration of 1 upon x plus 1, that is log x plus 1, and that's why this is 1 upon x plus 1. Okay, so 1 upon x plus 1, clear? And your integrating factor is 1 upon x plus 1. Now what is your solution? Integrating factor into y, that is equal to integrating factor into q, okay, into dx. So integrating factor is 1 upon x plus 1, okay, into y, okay, into y, that is equal to integration 1 upon x plus 1, okay, 1 upon x plus 1 into e raised to 3x into x plus 1, okay, dx. So e raised to 3x into this x plus 1 will be cancelled out. Now you have only e raised to 3x. So y upon x plus 1, that is equal to integration of e raised to 3x, that is e raised to 3x, okay, upon 3, and plus c. So y upon x plus 1, that is equal to e raised to 3x upon 3 plus c. Okay, so this is your final answer, y upon x plus 1, that is equal to e raised to 3x upon 3 plus c. Okay. So in today's session, we just discuss about linear differential equation and how we can solve general solution of linear differential equation. Your differential equation, make sure your differential equation in this type of dy by dx, just I mentioned here, okay, dy by dx plus px into y, that is equal to q, okay, and this is your integrating factor e raised to integration p dx, and this is your general solution. Okay. So, and in next lecture we discuss about Bernoulli's differential equation. Hello students. So now we are discussing on Bernoulli's differential equation. Okay, Bernoulli's equation type 1. In Bernoulli's equation there are two types, type 1 and type 2. Okay, so just you have to remember the general form of this Bernoulli differential equation type 1. Here you can see that dy by dx plus p of x into y, that is equal to q of x into y raised to n. That means p and q, okay, both are function of x and y. P of x and q of x, these two are function of x and y. Okay, so this is the general form of Bernoulli's differential equation. Now, if you want to solve this differential equation, you have to remember that first of all we have to assume that v equal to 1 upon y raised to n minus 1. Okay, this step is important, and after that this step is important. Your new linear differential equation, that is dy by dx plus 1 minus n into p of y, that is equal to q. So these two equations are important. Okay, dy by dx plus p of x into y, that is equal to q of x into y raised to n. So this y raised to n is an additional term. Okay, now first we want to convert this Bernoulli differential equation type 1 into linear differential equation. Okay, and we know that in linear differential equation, just I want to explain that dy by dx plus p of x into y, that is equal to q of x. Okay, this is our linear differential equation, but here in Bernoulli differential equation type 1, y raised to n, this term is an additional term, right? So if you want to convert this Bernoulli differential equation into linear differential equation, first we have to assume that v equal to 1 upon y raised to n minus 1. So in particular we can say that y raised to 1 minus n. Okay, we have to assume, and our linear differential equation, new linear differential equation, that is dy by dx plus 1 minus n into p into v, that is equal to q. Okay, this is my new linear differential equation. Clear? So let's try to understand first example. So dy by dx plus y upon x, that is equal to y square upon x square. So here when we compare, so p of x is what? P of x is 1 upon x, q of x is 1 upon x square, and y square, here you can see that y square. Okay, so n equal to 2. Clear? So what is my v? V equal to y raised to 1 minus n. So y raised to 1 minus 2. So y raised to minus 1. Okay, so first we have to assume that v is equal to y raised to minus 1. Okay, here you can see that 1 upon y, that is equal to v, and directly you can write this linear differential equation. Okay, what is my linear differential equation? That is dv by dx. Okay, dv by dx plus, here you can see that 1 minus n. Okay, dv by dx plus 1 minus n. Okay, here dv by dx, not dy by dx, sorry, dv by dx plus 1 minus n into pv, that is equal to q. So dv by dx into 1 minus n into pv, that is equal to q. So dv by dx plus 1 minus n, that is minus 1. P, what is your p? That is 1 upon x. Okay, and that is equal to what is your q? Q is okay, 1 minus n into q. Okay, here also the formula is 1 minus n into q. So that's why minus 1 into 1 upon x square. So 1 upon x square. So now this is your new linear differential equation, that dv by dx minus 1 upon x, okay, into v, of course. Okay, that is equal to minus 1 into 1 upon x square. So now what is your new q? Okay, this is your p, and you can say p1. Okay, so now your new p, that is minus 1 upon x and q. Okay, just I write here so you can easily see. P, that is equal to minus 1 upon x, and q, that is equal to minus 1 upon x square. Okay, p is minus 1 upon x and q is minus 1 upon x square. And now easily we can find the solution for this linear differential equation. Okay, that is v into integrating factor. Here you can see that first we find integrating factor. Okay, so integrating factor is e raised to minus 1 upon x. Okay, that is e raised to minus log x. So that is e raised to log x inverse. So final answer is 1 upon x for integrating factor. So the general solution is 1 upon x, okay, into v. Okay, integrating factor into v. Okay, that is equal to integrating factor, that is 1 upon x, and this is your q, minus 1 upon x square into dx. So integration is very simple, minus integration x raised to minus 3. So integration of x raised to minus 3, that is x raised to minus 2 upon minus 2. So 1 upon 2x square, okay, plus c. So 1 upon 2x plus cx, right? So 1 upon, and now put the value of v, that is 1 upon y. So 1 upon y final answer is 1 upon y, that is equal to 1 upon 2x plus cx. Okay, this is my final answer for Bernoulli differential equation. This is type 1. Now similarly, one more example you can easily solve. Okay, the equation is Bernoulli type. Here you can see that what is your p of x? P of x is 1. What is your q of x? Q of x is cos x minus sin x, right? And n equal to 2, right? N equal to 2. So when we n equal to 2. So when we assume that v equal to y raised to 1 minus n, so y raised to 1 minus 2, so that is y raised to minus 1. Okay, and what is your linear differential equation? That is this is the formula dv by dx plus 1 minus n into pv, that is equal to 1 minus n into q. Okay, so dv by dx plus 1 minus n, that is minus 1, so minus 1, p is 1, okay, v is what? Y raised to 1 minus n, okay, so pv, right, p is what? 1, so v, that is equal to 1 minus n, so minus 1 into q is what? Cos x minus sin x, okay. So your new linear differential equation is dv by dx minus v, that is equal to sin x minus cos x. Okay, that here you can see that, see, okay, this is my v, I assume v is equal to y raised to minus 1, so 1 upon y, and integrating, this is my new linear differential equation, right? Dv by dx minus v, that is equal to sin x minus cos x, I just write here, and now you can easily find the integrating factor, okay, e raised to minus x, and find the solution, okay, easily, right? Integration is very simple. So let's try to understand type 2. Type 2, for that we have this type of differential equation, f dash y dy by dx plus p f of y, that is equal to q. So first of all we assume that f dash y, okay, f of y is equal to v, so f dash y dy by dx, you will get dv by dx, right? And directly you can convert this type 2 Bernoulli differential equation into linear differential equation, that is dv by dx plus pv, that is equal to q. Okay, so this equation easily we can convert into linear differential equation, right? Here you can see that dy by dx plus 1 upon x, that is equal to e raised to y upon 1 upon x square. Okay, so first of all, suppose we divide on both the side e raised to y. So here you will get e raised to minus y dy by dx plus e raised to minus y upon x, that is equal to 1 upon x square, because this is your additional term, right hand side. See, okay, e raised to y is an additional term. What is our general form of linear differential equation? That is dy by dx plus p of x into y, that is equal to q of x. So right hand side, whatever the function of y, okay, whatever the function of y, that is your additional term. That term you have to divide on both the sides. So you will get this type of equation. Now here you can see that when I assume e raised to minus y, that is equal to v, and taking differentiation on both the sides, so e raised to minus y, okay, into dy by dx, right, that is equal to dv by dx, okay. And when I put this value, here, right, in this equation, so here you will get dv by dx, right, plus e raised to minus y, we already assumed that v, okay, so dv v by x, that is equal to 1 upon x square, clear? Okay, because we are taking integration with respect to x. So now this is your linear differential equation, and easily you can solve. Now your p is 1 upon x, q is 1 upon x square, okay, p is 1 upon x, q is 1 upon x square, integrating factor is, you can easily find e raised to integration 1 upon x dx, so e raised to log x, so x, and the general solution, because x into v, okay, integrating factor x, okay, x into v, because now your linear differential equation in form of v. So first we have to write v, and at last you have to put the value of v. So x into v, that is equal to integration x, integrating factor. This is your formula, x into integrating factor into v, integrating factor into v, that is equal to integrating factor into q, okay, into dx plus c. So what is your integrating factor here? X. So x into v, that is equal to integrating factor is x. What is your q? Q is 1 upon x square, okay, dx plus c. So x upon x square. So 1 upon x. So x into v, that is integration 1 upon x dx plus c, and 1 upon x integration of 1 upon x, that is log x. So log x plus c. Here x into v, that is equal to log x plus c. So v is equal to 1 upon x log x plus c upon x. Clear? So this is your final answer. Okay. So in today's session we discuss about linear differential equation, and after that reducible to linear differential equation. So that is ultimately Bernoulli differential equation. In Bernoulli differential equation there are two types, type 1 and type 2. Okay. So thank you.